find dx by 1 minus x into 2 minus x. Okay, so what we got partial fraction, a is equal to 1, b is equal to minus 1. So that means 1 by 1 minus x minus 1 by 2 minus x. Okay, this is between 0 to 0.9 dx using partial fractions. 1 by x integration log x. So this is while integrating you should divide by x coefficient. Okay, so this is 1 minus ln 1 minus x by minus 1 minus ln 2 minus x by minus 2, limits 0 to 0.9. This is minus x coefficient in both minus 1. So this becomes plus, this becomes minus. So ln of finally 2 minus x by 1 minus x using properties of logarithm log m minus log n, log m by n. So 0 to 0.9. If I put 0.9, 1.1 numerator, denominator is 0.1. So ln 11 minus, if I put x equal to 0, 2 by 1, that is 2. So log m by n, log 11 by 2, 5.5. So use your calculator. If it is not in the options, it is a suppose numeric question, then you should simplify. Natural logarithm 5.5. Now sixth question, which is asked in 2012 regarding areas. The area enclosed between the straight line y is equal to x and the parabola y is equal to x square in the xy plane is dash. This question asked in 2012, 2 marks. So I told you here now it is two curves. Whether you express y is equal to in terms of x or x is equal to in terms of y, then find the corresponding limits. If you express y is equal to in terms of x, find x limits, x values. Okay. So it is already given both are y is equal to in terms of x. So given curves y is equal to x and y is equal to x square. This is say equation 1, this is say equation. We don't know which is fx and which is gx. Okay. Anyhow, solving at the point of intersection comma we have x is equal to x square. Both y's are equal left side. So this is simplifies to x into x minus 1 is equal to 0, which implies x equal to 0 comma 1. So at 0 0 at 1 1. Okay, these are the point of intersection. So now you say without diagram also we can do the answer. So y is equal to x and y is equal to x square between 0 to 1. This is say 1. This is x axis. This is y axis. So this is origin, this is the point of intersection A. So this is the area, shaded part. Okay. This is say some P point, origin, x axis, y axis. This straight line y is equal to x. And this is the parabola y is equal to x square. So straight line is upper curve. So automatically this is f of x and this is g of x. Okay. So this origin coordinates 0 0 and p coordinates 1 1. Just see when x equal to 0, any one of the curves if you put and it gives corresponding y value. So x 0, y 0, x equal to 1, y is equal to 1. So 0 0, p 1 1 are the point of intersection. Okay. So this shaded part is the required area. Actual diagram is not required. Whenever the curve equation expressed as y is equal in terms of x, find this type of two x values and integrate between these limits the function. The function is nothing but here difference of these x terms. One is x, other is x square. If you get negative, then take modulus, because area never be 0 and negative. Area is always positive. Okay. So in some situations without diagram you can get the answer. Okay. So therefore area is equal to integral x is equal to 0 to 1 x minus x square. Suppose if you consider x square minus x, don't worry, you may get negative answer, but area never be negative, then take modulus. Okay. If by the time if you forget the diagram, etc. So simple coordinate geometry, equations, curves you should remember. Otherwise some problems are difficult. But this problem without diagram also we can get the answer. So x integration x square by 2, x square integration x cube by 3, limits 0 to 1. So 1 by 2 minus 1 by 3, answer 1 by 6 square units. Similarly, if you express the curve equations as x is equal to in terms of y, find two y values. One is lower limit, other is upper limit. Similarly, generally area is always positive. If your curve, after drawing its graph, if it comes below x-axis, if it suppose if any curve or a part of the curve comes into x-axis, comes below x-axis, then in that region area always positive. So you consider for that region below x-axis, area is equal to minus into the function fx integration. That means if your graph of fx lies below x-axis, the corresponding bounded area is taken to be integration limits with minus fx, so that area becomes positive. Now definition. First point, integral a to b f of x dx is said to be convergent if the integral value is finite. Otherwise, integral a to b f of x dx is divergent. So while integrating definite integral, if you get finite value, that definite integral is called convergent, otherwise it is called divergent. For example, see, integral 0 to 1 by x dx is equal to ln x between limits 0 to 1. So ln 1 minus ln 0, this is infinity. So this integral is divergent because the infinite value. Its infinity is not a finite value. Second definition. If the limits a and b are finite and fx is bounded, for every x belongs to closed interval a comma b, then integral a to b f of x dx is called proper integral. So limits must be finite and function is also bounded. Bounded means at lower limit x value is equal to a, or at x equal to b, or between a and b, take any x value, substitute in the function. That function value must be finite. That is called function is bounded. Okay. See example, simple example. 0 to 1 x square dx. So this is our fx. So this a value 0, this 1 value b. So at 0, 0 square is a finite. At x equal to 1, 1 square finite. Between 0 to 1, any number, 0.1, 0.11, 0.5, if you substitute square of that number is also finite. That is bounded. So fx is bounded. So this is proper integral. Three. If lower limit is equal to minus infinity or b is equal to upper limit is equal to infinity or both, then integral a to b f of x dx is called improper integral of first kind. Example, 0 to infinity e to the power minus x dx minus infinity to 0 e to the power x dx. Either upper limit or lower limit or both infinity. Okay, that is minus infinity or both. Then that integral is called improper integrals. Okay, minus infinity to infinity 1 by 1 plus x square dx. 4. If the limits a and b, both lower and upper limits, are finite, but fx is unbounded at one or more values of x belongs to closed interval a comma b, then integral a to b f of x dx is called second improper integral of second kind. Improper integral of second kind. Example, minus 1 to 1, 1 by x square dx, 0 to 1, 1 by x dx. So here limits both finite, but function is unbounded. That means becomes infinite at one value of x or two or more values of x between a and b, or at x equal to a, at x equal to b. So here fx is unbounded at x is equal to 0 belongs to closed interval minus 1 comma 1, and this is denoted by fx. At x equal to 0 it becomes infinity, is unbounded at x equal to 0 belongs to closed interval 0 comma 1. And remember, proper integral is always convergent. So this proper integral is always, you can write here, is always convergent. Any proper integral according to that definition I explained is always convergent. That means the integral value of proper integral is always finite number. Proper integral value is always finite number. Limits finite, function is bounded at x equal to a, at x equal to b, between a and b, that is in closed interval a b. That integration is called proper integral. Proper integral is always gives finite number, that is always convergent. This is improper integral of second kind example, simple. This is first kind improper integral examples. So these are the improper integrals definitions along with proper integral. So this question asked in (2008), 2 marks, which one of the following integrals is unbounded, question mark. A, integral 0 to pi by 4 tan x dx. B, 0 to infinity x into e to the power minus x dx. C, integral 0 to infinity 1 by x square plus 1 dx. D, integral 0 to 1 by 1 minus x dx. So in all the options, evaluate the integration using formulas and substitute upper and lower limit. If you get finite value, that is bounded. Otherwise, it is called unbounded. That is also called convergent divergent. Solution. A, 0 to pi by 4 tan x. So tan x integration log secant x 0 to pi by 4. So cos 45 1 by root 2, secant 45 is root 2. So substituting upper limit, which gives root 2 log root 2 minus cos 0 1, secant 0 is also 1. So log 1 value 0. That means so is bounded, because this is a finite quantity. So this integral option A is bounded. B, and this is a proper integral. This is fx, limits finite between 0 to pi by 4 and including 0 45 degrees, tan is finite value. So this is simple example of proper integral. 0 to infinity x into e to the power minus x dx. Using integration by parts, this is algebraic function or polynomial function u, and this is exponential function last, that is v function. So first function into second function integration, e power minus x integration minus e power minus x minus u dash x derivative 1 and v second derivative, second integration. E power minus x second integration means already first integration done. For this answer, one more integration. So plus e power minus x, limits 0 to infinity. E to the power minus infinity 0, e to the power 0 1, and 0 into any number is 0. So this becomes 0. I mean that first term vanished for both upper and lower limits, and this simplifies to minus 0 plus e power 0 1. So 1. So this 1 is finite quantity, integration is finite. So this is also bounded, since e to the power minus infinity 0, e to the power 0 value 1. C, 0 to infinity 1 by x square plus 1. It looks like 1 by x square plus a square value 1, so a is equal to 1. 1 by a into tan inverse x by a, so tan inverse x, limits 0 to infinity. Tan 90 infinity, so tan inverse infinity is 90. Tan 0 is 0, so tan inverse 0 is also 0. So this is pi by 2. Pi by 2 is also finite. So this is also bounded. So automatically option D is unbounded, because first three are bounded. Now 0 to 1, 1 by 1 minus x dx. So this is first kind improper integral. This is also first kind improper integral, but this is limits finite, option D. Function 1 by 1 minus x is not defined. That means 1 by 1 minus x is infinite at x equal to 1. So this is second kind improper integral. But anyhow it looks like 1 by x integration, ln 1 minus x, and dividing by x coefficient, limits 0 to 1. So minus ln 0, lower limit means putting minus and then put x equal to 0, becomes ln 1. So this becomes infinity. So E is unbounded. So this infinity means infinite. That integration value is infinite. So option D, integral is unbounded. So answer is option D, where the tick, the corresponding option is the answer, required answer. Now I am going to discuss properties of definite integrals. The purpose is, if the given definite integral is difficult or not known, then using these properties, it may simplifies the given integral. Okay, it may reduces to simpler integral. That means knowing the answer, knowing to evaluate. Properties of definite integrals. The first one, integral a to b f of x dx is equal to integral a to b without changing the limits, but function is f of a plus b minus x dx. Similarly, if I take a is equal to 0, b is equal to a, 0 to a f of x dx is equal to 0 to a f of a minus x dx. So that means x is replaced by sum of the limits, that is a plus b is nothing but sum of the limits minus x. X is replaced by a plus b minus x. Okay, so the later form, the right side integral, may become simpler. That means knowing to evaluate. Similarly, whenever the lower limit 0, then x is replaced by upper limit minus x, that is x is replaced by a minus x. So this is the identification arrow. Similarly, vice versa also. Okay. 2. Just a simple example, let me discuss. Example, integral 0 to 1 x into 1 minus x whole to the power 17. Okay, so this is, binomial expansion, binomial terms. It takes more time. 18 terms you will get, multiplied by each term multiplied by x, and then term by term integration takes lengthy. Procedure is laborious. So in such cases, this is your f of x, a value 1. Apply this result. So x is replaced by a minus x, that is 1 minus x. So this first x, outside x becomes 1 minus x. This inside 1 minus of 1 minus x whole to the power 17 into dx as it is, limits 0 to 1. Since a is equal to 1, comma fx is equal to x into 1 minus x whole to the power 17. Now, the later integral, this right side integral is now simpler form, 1 minus x into x to the power 17. Now in this way you will get product of 2 terms simplifies to 2 more terms. I mean, this is x to the power 17 minus, just multiplying. Now each is x power n standard integration formula, n is equal to 17, n is equal to 18. So x power 18 by 18 minus this is x power 19 by 19. limits 0 to 1. So 1 by 18 minus 1 by 19. This is first. Similarly, this question asked 2002 or 2000 long back, 0 to 2 pi x minus pi whole square into sin x dx. Okay. So let I is equal to 0 to 2 pi x minus pi whole square into sin x dx. So this is fx, a value 2 pi, a is equal to 2 pi. Now apply the above property, implies the left side I is equal to, let us say equation 1. In this integrand, fx is called integrand, a is lower limit, b is upper limit. Okay, replace x by 2 minus x, that is 2 pi minus x. X is replaced by 2 pi minus x, minus pi is already there, whole square into sine of 2 pi minus x into dx, limits integral 0 to 2 pi. Sine 360 minus theta, 360 minus theta is fourth quadrant, sine is negative, so this becomes minus sin x, and this becomes 0 to 2 pi pi minus x whole square into minus sin x. A minus b whole square is nothing but b minus a whole square. So therefore I is equal to minus 0 to 2 pi x minus pi whole square. I can write x minus pi whole square into sin x dx. So this is, now I can replace again by equation 1 I. So minus I, since by using equation 1. So left side I, right side minus I. So when left side is equal to minus right hand side, the only possibility is 0. When a number is equal to minus into a number is equal to minus into another number, when these two are equal, in the case 0 only. So bring that I minus I to the left side, I plus I is equal to 0, 2I is equal to 0, that means therefore I is equal to 0, that means the given problem is 0. Have remembered that sometimes in 11th standard, 12th standard properties, if you take the beginning step is I, then using that properties, you will get another, either I or minus I, adding 1 and 2, you will get 2I. Second property, property 2, minus a to a f of x dx is equal to 2 answers, 0 if f of x is odd function, otherwise 2 into 0 to a f of x dx if f of x is even function. Whenever the limits are same but opposite in signs, minus a to a, immediately you check the integrand fx is the odd function or even function. That is, I already given some standard examples, so that you save the time and steps also. One is answer 0, other is 2 into 0 to f of x dx. In the case of odd, 0. In the case of even, twice 0 to a. Okay, see. Simple example, this question is asked in 2014. The value of integral 0 to 2 x minus 1 whole square into sine of x minus 1 divided by x minus 1 whole square plus cos of x minus 1 dx. So zero to 2 x minus 1 whole square into sine x minus 1 divided by x minus 1 whole square plus cos x minus. You can apply property 1 also, okay? Or first you apply substitution method. Put x minus 1 is equal to t. So what is the substitution method again? It is also makes your integrand into simpler form, simpler function. Then we can identify which method is applicable. So dx equal to both sides differential, dx is equal to dt. Now x variable changing to new variable t. So your x limits also changes to new variable t limits. So how? As x equal to 0, if you put here t is equal to minus 1. As x is equal to upper limit 2 implies 2 minus 1. T is equal to 1. So t limits. Therefore t limits are minus 1 to plus 1. Now come back to this step. So minus 1 to 1 t square sin t divided by t square plus cos t. So this function now odd function. Why? Sin is odd function, t square is even function. Since t square comma cos t are even functions, sin t is odd function. Therefore t square into sin t, odd into even, is odd function. T square plus cos t, even function plus even, even. So numerator is odd function, denominator is even function. So finally odd function. Answer 0 using this property. Property 3 is 0 to 2a f of x dx is equal to two cases again. 0 if f of 2a minus x equal to minus fx, 2 times 0 to a f of x dx if f of 2a minus x equal to plus fx. So again, just like in previous property, two answers, but the procedure is small change. X is replaced by 2a minus x. In your fx, please verify one of these conditions. X is replaced by 2a minus x. Then simplify. If you get minus fx, answer is 0. If you get plus fx, answer is 2 into 0 to a f of x dx. Previous one is x is replaced by minus x, odd function, even function procedure. Okay. And the fourth property is 0 to n into a f of x dx is equal to n times 0 to a f of x dx if f of a plus x is equal to f of x. That is, a is the period of fx. You know periodic function, previous session I gave the formula, procedure. So this is, then 0 to a, 0 to 2a, 0 to 3a, 0 to n, n will come down. So n into 0 to a f of x dx, provided this condition is satisfied. And fifth property is 0 to a x into f of x. It looks like product of two external by parts, but if this condition, you can apply this property provided some condition to be proved. Answer is a by 2 0 to a f of x dx. That is, the product extern will gone provided this condition satisfied. F of a minus x equal to f of x. Sin x cos x period is 2 pi. Sin square x cos square x mod sin x mod cos x period is pi. Okay, this is 11th standard. 11th class standard examples, periodic function. And the last property is 0 to pi by 2 sin to the power mx or cos to the power mx. M is a positive integer. Answers two cases. Power is odd integer or even integer. Odd natural number, even natural number. M minus 1 by m, m minus 3 by m minus 2, m minus 5 by m minus 4, etc. so on. 4 by 5 into 2 by 3 if m is odd. Other answer is m minus 1 by m into m minus 3 by m minus 2 into m minus 5 by m minus 4 so on. 3 by 4 into 1 by 2 into pi by 2 if m is even. And combination of both, that is sin into cos, 0 to pi by 2 sin power mx into cos power nx dx is equal to m minus 1 into m minus 3 into m minus 5 so on 2r1 into same procedure for power of cos n minus 1 into n minus 3 into n minus 5 so on 2r1 whole divided by bracket m plus n into m plus n minus 2 into m plus n minus 4 so on 2r1. All these are multiplied by outside some k, where this k is equal to again two cases, two answers, pi by 2 if both are even, m comma n are even, otherwise 1, both are odd. That means both are odd or 1 is odd number, at least 1 is odd number. So if it is only sine or cos but limits are 0 to pi by 2, please take care about the last property. So what is the procedure? Subtract 1 from the given power and denominator is corresponding power. So it is a product of fractions where first fraction is whose numerator is 1 less from the given power and whose denominator is given power. Then there onwards successively subtracting 2 from numerator and denominator until to reach 2 by 3 or 1 by 2. If the power is odd number, you reach the last number is 2 by 3. If the power is even number, you reach the last number is 1 by 2. But if you get 1 by 2, in the case of power even, you should multiply. You should remember to multiply this pi by 2. That pi by 2 is extra. Okay? This is very important. If both are in product, sin into cos, same limit 0 to pi by 2. Sin power is denoted by m, cos power denoted by n. So, 1 less from the given power, m, that is m minus 1, go on decreasing by 2 until to reach 2 or 1. Similarly, all these are multiplied by 1 less from the power n, cos power, and then multiplied by the factors, go on decreasing by 2 until to reach 2 or 1. Whole divided by first factor in the denominator, add the powers, that is m plus n, go on decreasing by 2. All these are multiplied by finally k. That k is two answers, pi by 2, both are even. Otherwise, k is equal to 1. That is at least 1 is odd number, k value is 1. Please keep these points.